So this meeting will be a bit different than the ones that we had before, because today we're going to talk about programs someone else made and not the programs that we made. I hope it will be getting clearer soon why this can be interesting also for this course, because EEGLAB also gives you some handles in creating scripts that can be edited when you know how to program. So without further ado, let's go and install EEGLAB. I put the zip file in the course documents. To make it a bit easier, you can download it from the internet. You always have the latest version, but you need to fill in your email address if you want to. And to make sure that nobody has problems with that, I just put the download on the course documents. So let's first install EEGLAB. Installing EEGLAB is really straightforward. What you need to do is download the zip file and unzip it somewhere on your system. In this case, you can see that I installed it in my documents, but you can install it wherever you like. And installing is no more than unzipping. So I unzipped the zip file that I provided in my documents, and it leaves you a directory called EEGLAB and then a version number. If you look at the contents of that zip file, that folder, you can see it has several subfolders, and most interesting a EEGLAB.m file in the root of the install. If you got this far, you already have installed EEGLAB. So it's that simple. So after starting EEGLAB by pressing the EEGLAB.m file, or just calling it from the command window, it will open up this window stating that it's EEGLAB version 2021, and it has some suggestions to get started. One of the fun things for me to show you here is that it is possible in MATLAB to create more complex programs than we were able to program ourselves, that it's possible to use the functions that they provided in your own program. One of the things that is noteworthy if you open EEGLAB like this is have a look at your workspace. In the workspace, it will give you some variables now that are directly linked to the program EEGLAB. In this case, these are what they call global variables. We'll get into that later. The first thing that we need to do if we want to use EEGLAB, of course, is open a data file. Open a data file is opening you open a data file by pressing File and then Load Existing Data Set, and it will probably open the sample data automatically, the sample data directory. If not, just browse there. It's within the EEGLAB directory. And I want you to open the EEGLAB data set, which is the default demo data set. If you did so, it will give you some information about the data set that is open at that moment. So have a look at that. Okay, so after we did that, the information about the data set is being shown in the EEGLAB window. It tells me now that it has 32 channels per frame, which means that there are 32 channels of EEG data in this file. So that's 32 electrodes. The number of frames per epoch is the number of samples in the data. Because we only have one epoch, it has information about the sample rate and about the number of events that are in the file. those are all interesting parts of an EEG data file. I'm not going to go really into what an EEG data file, how to analyze EEG data, because that's not this course. But what you need to know is that all channels in an EEG data set are sampled at the same time. So there are always an equal number of samples for each channel, which means that the data from in MATLAB terms is a matrix. So it has 32 channels, 32 columns of, in this case, 30,000 samples. When we look at the workspace, you can see that one of the elements in the workspace is called EEG. The element EEG always refers to the currently active EEG data set. So if you double click on that, you can see that EEGLAB will save its data, will use its data from within a struct. It's a struct with several fields, and only a few of them are really very interesting. Well, most of them are interesting, but the data field, you can see that it's 32 by 30,504. So all the EEG data are in this matrix. There's also a times factor, which is the time axis for this data set. We have constants like MB-chan is 32. That probably reflects the number of channels. It has some commands. It has an S rate, which equals the sample rate, so that must reflect the sample rate. And it has some structs like the chun locks and the chan infos, which are info fields for each of the electrodes, stating the name of the electrode, which usually is a reference to its location on the scalp. And it has events, which is a vector of structs of events. If we look at them, you can see that they have a type, a position, and most importantly, most interestingly, a latency. That's the moment in time where the event took place. So all the information about the experiment that you did, the data that you're looking at, is available in MATLAB, also for your own programming. So if you want to do something that's not already provided within EEGLAB, you can always look at these values and do your calculations yourself. So that makes it very interesting. So if we go back to the interface, it's of course very interesting to look at the data like we just did by clicking on the EEG values in the workspace, but we usually just want to plot our data. Well, EEGLAB shows you does give you the ability to plot your data very easily by looking at plot, and you can see that there are many different ways to plot your data. And for data of this type, so the raw data. The second is the most usually chosen way to look at the data. Just look at the channel data and scroll them. So if you click that, EEGLAB will create a simple plot. You can scroll through these data, and you can you can see for each channel the information about the channel, in this case the name, and you can see the events as vertical lines in the data. And you can see the labels that these have in the top of the screen. Okay. So what we now learn, and what we probably thought of before, but now we can see it, is that in MATLAB you can make more complex interfaces than what we did when we created our paintings, for instance. MATLAB does show you does give you the opportunity to create buttons on the screen, which perform actions if you click them. It makes it possible to do interaction with your program on a more sophisticated level than writing scripts. What you need to remember is that we are still looking at a MATLAB program running. So in principle, this is no different from what you did when you created your masterpiece or any of the in-class assignments that you did. So being able to program does allow you to do very sophisticated things also in data analysis, which is the reason I wanted to show you this. So EEGLAB does allow you to do multiple things to your data. One of the things that is usually done is filtering. What filtering does is if you look at data, EEG data consists out of oscillations, which have certain frequencies, and filtering will take out a certain number of these frequencies that you're not interested in. There are many different ways to do that, to filter data. I'm just going to change the contents of my data set with a very basic filter, which is the default filter. It will ask me the lower edge and the higher edge of the frequency band that is a pass band, which means that in this interface, I'm not telling MATLAB which frequencies I want to take out of the data, but I'm telling him which frequencies I want to keep in. The data. So in this case, I want to say, for instance, all the frequencies between 1 and 20 Hertz, I want them to be in the data. I leave all the other information fields open, and it will use the default step. So I say OK. MATLAB will show you the frequency response of the filter, and if you're interested in that, there's a lot of information on that on the internet. But you can click that away for now, and it will ask you to save the new data set, because what it does, it creates a new data set from the old data set after filtering. It wants you to name it and then maybe save it as a file. You don't need to save it as a file, but you can. And what do you want to do with the old data set? Do you want to overwrite it in memory, or do you want to create a new data set? I want to create a new data set, so I will not mark this field. So after clicking OK, it will start filtering, and you can see that a #2 starts here, which means that there is a second data set open now. It still has the same name, but this is the filtered data set. So you can see in the datasets tab that there are 2 data sets now, and you can choose between those 2. The view of the data in the activities plot here is not changed because it is still the view that we had on the previous data set. So if you want to see the new data set, you make sure that it's active and you replot. And you will see that it looks quite similar, but it has less frequencies in there. So if you can look at both at the same time by doing it like this. So replotting. So now we have 2 windows open, and you can see that there is some difference in the data if you compare this part with this part, for instance. Okay. I'm sorry about that. I don't know how to record all these windows without showing my full screen. So we have a data set which is our second data set, which we created by opening the default data set, and we viewed it, and then we filtered it. A good question that you can ask now is, what does this tell me about programming? Well, EEGLAB has a very nice feature, the feature is that it remembers the steps it took to get to the data set that you are looking at. And you can look at what they call history scripts. So there are two types of history scripts: the dataset history script and the session history script. A dataset history script is associated with a dataset. So if you save this dataset, it will remember that it is filtered. And it has a session history script, which is the history of what I did in this session. If I say save session history script, for instance, it will ask me where to save it. Let's save it in the root of the EEGLAB directory, because that's the current directory, and then open it. So I asked EEGLAB to save this script, and now you can see there is a new M file in my current folder, and if I open it, it has all the commands that created this data set with all the plot commands and the filter in there that we performed to create this data set. Sorry. This allows us to rerun this script and recreate our all the steps that we took in our analysis for instance, for the other subjects within this experiment. The current file that all these transformations are performed on is in line 4. In this case, it says it's the EEGLAB data set. This could be a data set that pertains to one particular subject, and you can create a for loop here, as we learned in this course, and do the same and changes to our data set, the same artifact recognition, filtering, etc., for each subject in our data set by changing these parameters. So if you run this file now, instead of running EEGLAB, you can see it does exactly the same things that it did, that we did before. So it's opening the files and it's showing our filters, and it's opening each of the steps that we did. It's redoing them. Some of them are not interesting for us. Oh. This is the demo problem. Always something going wrong. But let's ignore that. I know I clicked a window away before it was used. But you can also just take out steps if you did them double, or so this is a fully editable history of what you did. So I think it's a very neat way to also get information about how EEGLAB allows you to do certain transformation, like the filtering we just did, in a programming way. If you want to get more information about how to analyze data, EEG data in EEGLAB, I would really suggest that you go to the website that we have here, eeglab.org. It has the tutorials, and it gives you all the information about how to do analysis of the data. For us, interesting is to see that EEG data is not different from the data that we looked at before. It is in principle EEG data is no more than a struct giving information about the recording, the frequencies and stuff like that. But most importantly, it's the data field, which is just a matrix of the data. So I hope that I was able to show you in this short video that MATLAB is capable of making that you should be able to create your own programs in MATLAB, which can go far beyond what we did during this course, creating simple scripts and creating functions. But this will not be part of the curriculum. This will not be part of the exam. So I will not ask you to use EEGLAB in the exam. But I think it's very interesting to see that that MATLAB is capable of creating interfaces, and it's creating and it's doing all these more elaborate things like filtering, and you can use that in your own programs. But as I say, for the exam, this will not be part of the curriculum. In the in-class assignment for today, I will ask you to make some signals yourself, some sinuses, some tones, and you can. And I will show you that MATLAB is also capable of creating sounds and making sounds audible. So that could be interesting for you. I think it's always a lot of fun, and it will teach you a lot about what data look like. And so I will try to upload a practice exam before the day after tomorrow, so we can talk about that the day after tomorrow, which will be the last time that we are together. Yeah, looking forward to seeing you tomorrow. Bye.